already out, and you'll definitely want to make sure you start looking at it. It's pretty short. I think you guys will get through it quickly. Tomorrow we'll look at a workday on this stuff, and Friday we'll start 11.2, and we should be in good shape. Okay? All right, so let's roll, kids. 11.1, we're still dealing with what shape in this chapter appears?
Circle.
Looking at circle stuff, okay? Circumference and arc length specifically. Volunteer to read my question for me.
How can you find the length of a circular arc?
Okay, so we first of all need to know what a circular arc is. What do you think a circular arc is?
Arc on a circle.
Okay, what do you think circumference is?
The distance
perimeter
around
of
the circle.
So it's the perimeter or the distance all around. You guys know this already. So the arc length, is that the whole circumference or part of the circumference?
Part.
So we're going to be looking at parts of the circumference. So today, in order to answer this question, how do we find that length? We're going to use the formula for, first of all, what? Turns out there's two of them. Secondly, we're going to look at using arc lengths to find measures, look at some real life problems, and then we're going to measure some angles, and this will be very new for you today, right here. Measure angles and what, kids? What's that say? Radians, okay? Kids, just so we talk about this here, circumference. The circumference of a circle is the distance around the circle. I like the way you put it, Grace. You said it's the perimeter of the circle. I like that a lot, too. Circumference is found by two formulas. What's the first one right here, kids?
C equals pi times...
Pi times diameter. We'll approximate pi. You should know this to be about how much?
3.14.
Okay, we'll approximate 3.14. Your calculators pretty much have a pi button in them now these days, don't they?
Yeah.
Okay. All right. Or, guys, the diameter is made up of how many radii I put together? An alternative formula right here then would be, instead of pi times diameter, we could do what?
Excuse me, 2 times pi times radius.
2 times pi times the radius, okay? All right, so here's the other part of this, then the arc length. The arc length of a portion of the circumference of a circle, okay? A to B right here in red. This A to B right here, that would be considered an arc length. Is that the whole circumference or part of the circumference?
Part of it.
Okay, it's a portion of it, all right? One term that'll be very new for you today, guys, is this, radian. I need a volunteer to read that definition of radian for me.
For a circle with radius r, the measure O, an angle in standard position whose terminal side intercepts an arc of length r.
Okay, so we're actually going to change this O to be Greek letter theta, like this. It's an O with a line through it. This is the angle right down here, all right? Guys, here's the deal. Call this angle theta right down in here like so. Okay. Here's the deal. This 1 radian on the line right here looks like a what from here to the end? It's like the radius, okay? What a radian really is taking 1 radius, laying it out here on the curve, and then saying this is 1 radian that goes around here, okay? So this distance right down here for a radian r, this r is the same as this distance r up there, okay? 1 radian is the length of a radius put out there. It's the arc length of the radius, okay? So if a radius was 7, then 1 radian would be how many units long and for an arc? 7, okay? If you can think of the radian as 1 radius, then think about it. Now guys, think about it. What's the whole distance around here from this right here? How do you use this formula to find the whole distance? Well, you would take 2 times what? So my question is, how many r's do you need to get all the way around here? 2 what? 2 pi. So what we say for this right here is this. There are 2 times pi radians in a circle. And again, a radian is the same length as a what? Radius. Well, I would take the radius times what to get the circumference? 2 times what? The only thing you need to understand about a radian is a radian is the same length on the circle that's equal to the what? Radius. Okay, and how many radians are in a circle? Because this is kind of like saying 2 pi r is the distance all the way around there. Okay, so just note that right now, and we'll come back to it. Okay, first page. Are you guys cool?
Yeah.
Okay. Then, next page here. So, circle, you know that, I don't need to draw it. It's a set of all points in a plane that are equidistant from a given point. All right?
It's like a same
Okay. Diameter, you guys know diameter, and you should know radius. So do I need to go through these at all?
Nope.
Okay, you can read these. We should know these. I mean, we talked about so much in chapter 10, so prior knowledge. Okay, core concept right here. What are we talking about, kids? Circumference of a, okay, the circumference of a circle C is equal to pi times diameter, or 2 pi r, where d is the, and r is the, okay, these formulas down here show up again. So example 1, let's just talk example 1. This one here is kind of tricky. It says, find each indicated measure. Find the circumference of a what? With, okay, there's 2 formulas up here to use, kids. I don't care which one you use, but I always like to write one down. I like to say C is equal to, in this case, they gave me the what, kids? So I'm going to use the 2 pi r one. Is that okay? And we'll go to the nearest tenth of stuff. I do want to check something real quickly. Give me 1 second. I don't know if they want us to leave this in terms of pi or if they want us to measure this out. So, just give me a second.
He walks in with toilet paper.
So does anybody have an explanation for what just happened?
I guess that toilet paper in there just hurts too bad. Like, I feel his pain, honestly.
It feels like sandpaper on your butt.
Yeah, it does.
Alright, enough.
Jeez, Eli.
Wowzers. Sandpaper. Okay, I want to check something real quickly. Give me 1 second. Don't worry.
This stuff burns your mouth. It's like,
Okay, let's do this, kids. Let's do this. What are you going to plug in for R, kids? Okay, you guys get your calculator out. I'll get mine out. We'll see if we agree. So I'm going to go to, do I have a pi button up here, guys? Anywhere?
yeah.
I don't think.
Probably.
Maybe.
I don't know.
I do. 2 pi.
That's a long time.
So I'm going to go 2 times pi times what, kids?
11.
So the distance all the way around my circle. Let's just go to the nearest, let's go 2 places on these, okay? They might, in your assignment, go nearest 10th or nearest 100th. One way I could write this, what's the 2 times 11, kids?
22.
What would that 22 represent in the circle?
Diameter.
Okay. You could leave your answer as 22 pi inches. Or if you multiply that out, what did we get for an answer? Maybe to 2 places. 69.11,
1, 1.
or you probably round to 1, 2. Guys, chill. Okay. All right, part B this time then is a little different. Instead of telling you what the radius or diameter is, they're saying, hey, we know the circumference is what? 4. We need to find the radius. Okay, so here's how I'm going to do this. I'm going to say, well, I know that the circumference is equal to 2 times pi times the radius that we need to find, but we know the circumference is how much?
4.
So what are you going to plug in for C?
4.
Gosh, could I divide both sides by 2 to begin with, kids?
Yeah.
So this would make this 2 equals pi r, wouldn't it?
Yeah.
So how would you solve for the radius, kids?
Divided by pi.
2 divided by... All right, so let's do that real quickly. Why don't we punch that up? We would go 2 divided by pi, and let's go maybe 2 places, so about point what?
6. 4.
And what's the unit I want to use, kids?
Millimeters.
Okay, so this from this, r would equal 2 divided by pi, which is about 0.64 millimeters. Okay, so I'm telling you, start out with the formula here. If they're talking about radius, use the second one. If they're talking about diameter, use the first one. Okay, that's simple. You should know that. I mean, that's review. But we're going to use that concept to start talking about the things that we need to understand. Title was circumference and what?
Diameter.
Arc length.
Arc length. Okay, we're going to start looking for part of the distance on the outside here, okay? All right, any more here at all?
No. We good.
So here's a biggie. This core concept, this is pretty important, kids. This core concept, pretty important right here. I think you should highlight this, star it, do what you need to do, but this is pretty important today. Okay. First of all, core concept here is going to be about arc length, all right? Somebody want to read the core concept for me
Yeah.
first? Go ahead,
In a
Keegan.
circle, the ratio of the length of a given arc to the circumference is equal to the ratio of the measure of the arc to 360 degrees.
Okay. So what they're saying is this, kids. How many degrees are there in half a circle? Isn't 180 half of 360? Okay, so if I have a semicircle, isn't that arc on a semicircle going to be half of my circumference? So what they're saying is we compare the central angle inside to how many degrees in a full revolution?
360?
You take your arc length over 360. I'm sorry, your central angle over 360. And you compare that to your arc length over your whole, what's the whole distance around the circle called again? Circumference. They give you this formula right here. It says the arc length of what? AB over what, kids? 2 pi r is equal to the measure of arc AB, or the central angle over 360. I'm going to make this a little easier for you. Is that okay?
Yes.
This is what I think you should write down to remember it. Okay? This is going to stand for AL over, what's capital C going to stand for? Okay, the ratio of the arc length to the circumference is going to equal your, I write my central angle like this, my measure of central angle over how many degrees in a whole circle? Okay, I think that this is an easier way to remember it. The arc length is to the circumference. Part of the circumference to the whole circumference is equal to the central angle over a whole revolution of 360 degrees. Okay? So let's see if we can apply that right here, kids. Arc length over what, kids? Is equal to central over... Okay, let's see if we can't figure this out. Example 2 says using arc lengths to do what? Okay, what are we trying to find the measure of right here?
The arc.
We need to find that arc right there. Okay? Very simple to do. Okay? Do we know what the arc length is out here? No idea. So I'm going to call it length x out here. That's what we're looking for, right? Now does x represent a central angle or an arc length? So I'm going to say my arc length, x, is to the circumference. Kids, do we know the circumference?
No.
But could you find the circumference?
Yes.
How would I be able to find my circumference here?
2 times pi times 12.
So 2 times pi times 12. Very good. Okay, that's going to equal the central angle. Do you know the central angle, kids? For this arc length PR right here, we defined it as x. What central angle tends to that? 100 degrees, right?
Yeah.
Over a whole revolution, which would be what?
360.
Those ratios are proportional. Here's what I need. I need someone to evaluate 2 times pi times 12, 2 places for me.
Wait, that's.
75.31.
So 75.40, want to go? So call it 75.4. Kids, how are you going to solve for that arc length right here?
Times 75.4 by 100 and then divide by 360.
Okay, so it's just a proportion. Cross multiply and divide. Is that the way I understand it there then, Grace?
Yeah, we do that.
Cross multiply, divide?
Yep.
Yeah.
Okay, so you're going to do 100 times 75.4 and divide by 360.
21.
Oh, 20.94,
Yeah,
21, somewhere in there. Okay, so I'm going to call it 20.94. Are you guys okay with that?
Yeah.
try another one here, kids. This time we have to find what? Oh, lordy. Circumference?
What's that?
Oh.
Well,
I have a question here. What do we know in this one?
we know the central angle.
We know the central angle. We know the arc length.
Yeah.
Okay. But the only thing we have to do is find what?
Circumference.
And if you go back up to this rate up in here, we would know the arc length is to the, as the central angle is to. Okay, so let's just fill that stuff in. What can I fill in for arc length here, kids?
6.5.
So 6.5 is my arc length. 6.5 is to, do we know the circumference at all the way around here, kids?
No.
Can I just put capital C down here then?
Yeah.
As,
130 over 260.
hey, quick question. Should the arc length be more than 6.5? I'm sorry, should the circumference be more than 6.5 or less than 6.5?
More.
Better be more. Okay, so cross multiply, divide that. Tell me where you're at, kids.
Okay.
I'm here at 18. What are you guys getting?
18.
Okay, so when you cross multiply and divide, what's the circumference?
18.
I have a question here now. And this would be 18 what?
Meters.
Once I found the circumference, would that allow you to find the diameter?
Yeah.
Once you found the diameter, would that allow you to find the radius?
Yeah. That's pretty cool.
So can we go further with that?
Should we?
I don't know. What are we asked to find here, kids?
Arc JK.
Okay, I want you to try that one on your own, see what you get. So go ahead and take a shot at part C. Again, arc length is to, as central angle is to.
360.
Okay,
Wait,
just remember that arc length is to circumference,
Wait.
as central angle is to 360. It says find that arc. Well, it
says find the measure
of arc what?
JK, but it's 21.
Okay,
It says 21 though. So what do we have to do with it?
I don't know. You tell me.
You tell me, I'm asking.
I don't know.
I think we're done with it. Just put that one.
Do they want the major or minor arc?
Well, yeah, I think that they worded this pretty poorly. I think that
Yeah.
what they want is the angle, the central angle, because here's the deal. Do you know the arc length right here?
Yeah.
Yeah.
Okay, the thing we don't know, guys, is the central angle. Would you agree with that?
Yeah, we can find that.
So I could say arc length of what here, guys?
21.
Okay. And the thing I want you to understand is this. When they start saying what's the measure of arc JK, this here is going to mean angle now, okay? Because over here, notice how they wrote this in part A?
Arc.
They write the words what?
Arc length.
What is the arc length, okay? So when they say measure of JK, that's the measure of an arc in degrees, which would be the same as my central angle there, okay? So 21 is to, oh, guys, do we know the circumference down here?
No.
I would have to take 2 times pi times what radius?
14.3.
That's going to equal the central angle. Do we know it up here?
No.
Is it okay if I call that central angle x up there? Over how many degrees?
360.
All right, I need somebody to punch that mess in. 2 times pi times 14.32 for me.
Yeah.
I'm sorry, 89.4? Okay, so this is 21 is to 89.4, as that angle is going to be to how many degrees? Okay, so what are you going to do to solve for that angle? Cross multiply and divide.
Divided by 89.4. Is that 89?
I got 89.97.
Did you do something wrong?
Okay. How many are getting 89.97 there?
I got 84.6.
Let's run it here. Do we all agree with the 89.4 down here?
No, that's what I was.
No.
What did you say you got?
89.975.
Let's do this. Did you? How many are punching 3.14 in your calculator?
I'm using the
I got
pi button.
85.
How many are using the pi button? Raise your hand. How many are using the pi button in your calculator?
I'll do it real quick.
How many are using 3.14 in your calculator? Let's do the pi button. Okay, let's go 2 times what? Pi times what? 14.32. 89.97. Is it okay if we run that up to 89.97, guys? Are we okay with that? Sonny, did you use 3.14?
No.
Run your numbers again.
I got 89.975.
Yeah.
Now we got.
Okay. Are we good now? I don't know what, you type something in there. Okay, so let's go cross multiply and divide. What have you guys got? And I'll confirm this. Guys, I'm coming up with about 84.03 degrees. Are you guys?
Yeah.
Yep.
Okay. So the measure of this arc angle right here in terms of degrees would be, so from this we've got 84.03 degrees right in here. Okay. Again, really what you need to remember is this. Arc length is to circumference as your arc angle or central angle is to, you bet. If you can just remember that today, I think you'll be in great shape, all right? Okay, let's look at the last example on this page right here. I like this example. It says using circumference to find what?
Distance traveled.
It says the radius of a wheel on a toy truck is 4 inches to the nearest foot. How far does the wheel travel when it makes what? Well, isn't one revolution like taking the whole circumference and laying it out flat?
So 360 times 7.
Okay. Well, we got to be careful on this though. But what's really happening here is this: we have a wheel that's going to travel that direction right there. Guys, do you agree that when I make one revolution is like going the distance of the circumference on this circle?
Yes.
Okay, so if I roll this one revolution, isn't one revolution right here equal to my circumference, which is pi times, well, this one here gives us a radius, so it would be, which would be 2 times pi times, what is the radius there, kids?
4.
Okay, so tell me how far it goes in one revolution, kids. .13 inches. But how many revolutions does it make?
7. 175.9.
So how did you get that?
I multiply it by 7.
Yeah, if one revolution is 25.13 inches, you all understand how we got that, right?
Yeah.
We turned it one whole revolution, or rolled forward one whole revolution. That would be 25 inches forward. But if I want 7 revolutions, we're going to take 25. So 7 revolutions would equal 7 times what, kids?
5.43.
What'd you say? 175.91?
93.
93? Okay. Again, figure your circumference and say, all right, well, the circumference is really the equivalent of what, kids?
1 revolution.
But we're really going how many times around there?
I did the same thing, but I got 175.91.
You all good. As long as you're in the ballpark with
Calculated
this,
it.
I'm okay with it. And again, I don't know how they're going to ask you to round stuff on the big ideas. Questions on that example? Gavin, you have one? Where's that 4 coming from, kids?
Radius.
Right up here, Gavin, it says the radius of a wheel on a toy truck is what?
4 inches.
You okay with that? You understand where that came from now, Gavin? Okay. Anything else about that example before we move?
No, we're good.
How you feeling? All right, last the page. Let's talk, kids. I'm going to see if you can do this one on your own. It says using arc length to find what?
Distances.
Okay. It says a path is built around 4 congruent circular fields. The path here is kind of on the outside. It says the radius of each field is what? 100 feet. How long is the path? Round your answer to the nearest.
100 feet.
How about thoughts? We have to find the distance around or the perimeter of that green figure up there.
We have to find the circumference of the 4 circles.
How much? What'd you say? Okay. Guys, is there any way to find the distance of each corner here?
Yeah.
Okay, let's talk about the distance of each corner, rounded corner. How are you going to find that? Let's start with a corner first.
Well, we know the central angle. Wait, no.
Okay, so you know the central angle.
Mm-hmm.
How much is that?
90 degrees.
So I could say the central angle of 90 degrees over what?
Over the 100-foot thingy.
260.
Okay, what's the formula I've asked you to remember? Arc length is to circumference as central angle is to.
360.
Well, we have the central angle part and the 360 part all established, so talk to me. How am I gonna, do we know the arc length out there?
No.
Do I know the circumference of those circles?
No.
Yeah.
I could know them, right?
Yeah.
It would be 2 times what?
Pi.
2 times pi times a radius of how much? Okay, so run that. 2 times pi times 100. 628. Okay. Point how much? Okay. Find me a corner.
There.
157 point. And what unit should I use here?
Wait, how do you make that?
Feet.
Oh, never mind.
90 times this. Okay. So each corner is how much, kids? By the way, how many equal corners do you have?
4.
Okay, so let's just talk about this. We've got the corners, each are 157 point. What'd you say, Sonny?
1.
Okay, how about the straight edges? Say maybe from here to here. Any way to know that? Watch what I'm doing up here. This is a radius. What would the distance from here to here be?
100.
What would the distance from here to here be?
100.
Oh, it's going to be 200.
Why 200?
Because
Because this radius is 100, isn't it? And this radius is 100. Doesn't this vertical distance in blue match the distance over here on the right side? How much are each of these sides going to be?
200.
Okay, so we have each side, or each straight side, if you will, being how many feet?
200.
Okay, so let's talk about this. How many corners at that length do you have?
4. You don't even really need to divide it by
Not really, do you? Okay. How many sides do you have at this length?
4.
Okay, so what do you have total for corners then? If I took this times 4,
It's 28.
okay, so you're saying we're going to take 4 times each corner, which is 157.1, plus each side, which is what? Okay, somebody take 200 plus 157.1 there. What do you have?
357.
You're going to take 357.1 because that's really, this in parentheses is one side and one corner, but we have 4 equal sets of sides and corners. So what's 357.1 times 4?
1,428.4.
1,428.4 feet. Very good. Very good. Is this clicking today, guys?
Yes.
Give me a show of thumbs. Up, down, side. We good? We be good. All right. Well, I think that you guys have a great handle on this. I think something that's going to become very new for you today is this. We're going to start talking about this idea of degrees to what?
Radians.
Okay. Take a look at your definition of radian again, back on the front page.
For a circle with radius r, measure O, an angle in standard position whose terminal side intercepts an arc of length r.
And over there in the notes we wrote down, there are how many radians?
2 pi.
Okay. This here says converting degrees and radians up here as our core concept, right up here. Okay. This here says how do you turn degrees into what?
Radians.
Okay. If you're going to start with degrees and go to radians, here's the trick. This is the rule. I'm going to make this very simple. They try to make this very difficult for you. I'm going to make this very simple. Are you okay with this? What you're going to end up doing to turn degrees to radians is you're going to take your number of degrees and times it by pi over 180. Okay? If they ask you to convert degrees into radians, and it's going to be pi over 180. Now again, think of it this way, kids. Watch what I write over here on the left. We said there's how many radians in a full circle?
2.
And a full circle being how many degrees? Do you guys agree that I could take 2 out of both the top and the bottom? If I take 2 out of here and 2 out of here, what's the bottom become?
180.
That's where that pi over 180 value is coming from. There's 2 pi radians and a 360-degree revolution. Okay? So if going from degrees to radians meant multiply by pi over 180, what do you think the opposite is to go from radians to degrees? Instead of multiplying by pi over 180, what do you think? 180 over pi. Yep, reciprocate. So degrees, if you start with radians, to turn that to degrees, you're going to take your radian measure times 180 over what? Okay, let's see how this looks. Okay. This here says convert what, kids?
30 degrees.
To what? So we have 30 degrees to start with. We're going to take that times. So this becomes 30 times pi all over 180. Okay, now think of it this way, kids. Is 30 over 180 able to be simplified? So what? What do you know? Whole 30 go into both of those? How many times up top?
6.
Up top, 30 would go into 30. So up top, this is really 1 pi over what? 30 degrees is equivalent to what? How many radians? Pi over what? Okay. All right, so let's do the opposite. Let's convert radians to what? So if I'm going from radians to degrees, we take the radian measured times what? Okay, so if you have radians right here, how many radians are we starting with here, kids? 3 pi over 8. We're going to take that times 180 over pi. Now I love this right here because what does the pi value up top do to the pi value on the bottom here? So what we end up doing is taking 3 times what up top?
580.
Which is 540. What's still on the bottom, kids?
8.
Somebody run 540 and divide that by 8 for me, please. 67.5 degrees. 3 pi over 8 radians is equivalent to how many degrees? Okay. We're going to be doing a lot more with radians as we move forward in this chapter right here. But right now, the thing you need to understand before we can move forward is how to convert from degrees to what? If you start with degrees to turn it to radians, what do you multiply by? And if you start with radians to move back to degrees, you take your radians times. Okay, that's all you need to know right there. All right? Kids, what questions do you have for me?